Hello everyone, welcome to Learn Overflow. Hope you all are doing well. So, in this video, I will talk about the conversion of an image to a sketch image, a colored image to its pencil-like sketch using Python. So, I will move on from step by step from taking an colored image, going from its grayscale and the various other steps, converting that image, and finally generating a pencil or sketch of this video. So don't skip any steps. I will explain it everything. Watch till the end, and I will make sure that everything is clear to you. In this video, we will try to convert an image to a pencil sketch using our Python. So we will give this our program an image and .jpg file, and we would try to get a pencil sketch like image, a sketch image that we usually draw with hand. So we'll try to generate that image using Python. All right, we are not using any kind of machine learning libraries or something high-end libraries, but for this I will use Python Opencv library. So Opencv is an library that helps in image manipulation. So if I just show you on uh, Google like what's OpenCV, you will let to know like, so OpenCV is an library for programming functions, and it's mainly aimed for real-time computer vision. So this is the library that we use for all kind of image or that stuff. Whenever this class, mostly we use an OpenCV library. All right, so here we will be using the OpenCV Python library, and this is the way you can install it. Just right click install OpenCV Python and it will get installed. So these are the processes that you need to follow. And while importing the library, while using that, you need to use import cv2. Remember, we don't write opencv import opencv, we write import cv2. All right, so these are the informations here, and these are the other things that you get to know about this library, and we will use this library one by one, like throughout the program to get our um, program done, like to build our program. All right, so let's move back to the editor and let's start with our favorite task, that's coding. All right. So first thing we need is our OpenCV library. So import CV2. Import CV2. We got our CV2 OpenCV library. Also, we may require some other libraries, but let's see if whenever we would require some other, we'll just import them one by one. So first thing first, we need to read our image. Like we need to get our image as an input. The image, that original image, we will print or we will just convert to a sketch. All right, so let's say we get an image. So I name it as an image. It's a variable name I put as an image. So I will use cv2 here. Cv2 dot we'll say imread. So imread is an imread is an function of the cv2 library that helps us read an image. So I'll just leave this blank. I'll just add an image in some time later. So let's build the whole thing and we'll add an image soon. All right. So next thing, we got our image. Now we need to convert our image to an grayscale, right? We need to grayscale the image. So for that, we say that gray image or im uh, gray all right, let's keep the variable name like this. So we'll say gray image is cv2 dot we will use that cvt color, and cvt color is an library that helps us to change the color. So we'll say convert our image to, we'll convert our image to cv2 dot cv2 dot its color, or its color BGR to gray. Okay. BGR to BGR to All right. So we converted our image, get our gray image. So now let's in the next step we'll just convert this gray image or invert our gray image. All right. We'll invert our gray image. For that, we'll do gray image invert. We'll invert a gray image and we'll say 255 minus, this is the 250 is the pixel count minus our gray image. All right. In the next step, we'll make this gray image in a Gaussian blur. So we'll again say, or rather, we can do it here directly. Uh, we can directly move find Gaussian blur here. So we'll say cv2 dot Gaussian blur. Yeah, cv2 dot Gaussian. Yeah, cv2 dot Gaussian blur, which is just put a Gaussian blur in this, and here we'll provide our gray image invert. So what's gray image invert is basically 255 minus our gray image, and we'll convert it with this say in an order of 21 comma 21, and we'll use it with 0. Once we gave our source, we gave our source as 255 minus gray image. Then we gave our k size. So k size is 21 comma 21, and then we gave our sigma x value, that's 0. All right, we gave our sigma x value, that's 0. After that, we got here. Now we will get our output image. So what's the output image? We'll say output. We'll say output, and in this output we'll get our output. So cv2 dot will divide our image in we'll again use our gray image. I mean that original image. So no, this gray image, we'll use this gray image and divide it by this with a scale of 256. All right, let's get our gray image. So gray image, and we will divide it by 255 minus gray image invert. So basically 255 minus gray image invert, and we will use a scale of its auto value. The scale previous value is none, so we'll change this to 256.0. All right, we gave a value to a scale. Now it's time for output. So in output, what we'll do, we'll say take cv2. The similar way we got our input is in imread. Similarly, we can give our output as first before we actually give imshow. So imread and imshow are the part that we use. So before we actually give an imshow, we need to get the window fixed. Like we need to fix our window with a particular dimensions, right? So for that, cv2 dot name the window. So cv2 dot name the window, and we'll say uh, this is our sketch, and we'll say and with this we need to give a flag. So flag is cv2 dot window auto size. Yeah, window auto size, cv2 dot window auto size. This would make this window, and that you may print out an image in an auto sized mode. All right, next, moving on, we will show our image. Okay, so again cv2 dot im show, and we'll show our image. We'll say this is the so this text that we're giving here is a print text, and that's the window name. So we'll say sketch, and we'll pass it to our output. Will print our output. This will show our image, and after that we need to give a cv2 wait key so that it don't close it directly after we run it, and we give it a wait key, and then we will close it like cv2 dot destroy all windows, and this will close the program finally. So let's run it and let's check what it does in our case. Oops, I made a mistake. Wait. I didn't pass here any image, and guess it would give you an error. No worries. Wait a second. All right, so I just added here a video. I just added here a image, and this is the image we have here. So let's run this and see how it works. Look, this is how the image got into a sketch image. All right, this is working. So let's see other things. So um, what if I just show you the alternatively, I just show you the original image by side how it got produced. So in that way, I'll just add that and main the main image. I'll just add the main image alongside so that you can find out. So I'll say original, and here I'll say again the similar things. If we do not go into auto size, and there we go. And after that, we need to again show that cv2 dot um, cv2 dot I am show, and we'll show here the our original one, and we will say this is the first image where, so we'll print our image here. All right, so you can see both the images side by side. Let's run this. Look, this was the original image of the van. Look, this is the original image of Guido van Rossum. Sorry if I'm pronouncing his name wrong. Uh, this is the original image that I took as an input, and this was the sketch that the CV2 library gave us. You can see that the sketch looks almost equal. It looks the same. So Python did like the CV2 library of Python did a great job. We need to say. Let's close this, and let me show you one by one the other stuffs we have here. So here after image, you saw that I just took a gray image. Why not I just print out this gray image to you, and you can identify, you can understand what we are doing in this line number 4. All right, so in this case, I'll just keep our original image as a comment line so that we don't need to, I can show you easily for that. Now, look, this is the gray image. So originally it was a colored image, and gray image converted it to a non-colored one. I mean, it converted it to a black and white image. All right. What if I show you this gray image, inverted image, the second one you can see here. So what if I show you this, and you can say what it does. Look, this is the inverted one. We just changed the color, right? So wherever it was dark, we just convert it into black, into light, and wherever it was light, it converted into the dark one. So when you divide this light and dark one, the original one was a look. I'll show you how this actually works. So let me just, why not? We just, no, not this one. So this 255 minus gray image, so we can show you, let's say I put it X here, and oops, I'll just show you X is this 255 minus this, and I show you what X is. Now let's keep that original image side by side so that we can see how our image is going on. All right. So this was our original image. Now, all right, I'll just take one more step, one or two more steps, and I'll just say this. We will print here our gray. After that, I'll print again. I will say this is our X. After that, I'll again say we will take it as gray inverted one. So why not take all of this side by side and learn how is this going? All right, so this is a sketch. So sketch was our output one, and I'll just print her. So after image, we will create gray, we'll show a gray, then we'll show our X1, and then we'll show our gray inverted. Now see what the step by step it does for us. It will open up 5 libraries. Yeah. So this was our sketch, our final one. This was the original one. This was the gray inverted one. I'll just this was the gray. I guess it got some error or oops. Sorry, I made a mistake again. I'll just print that part here. So we got our image. We got our here. We will say gray image. In the below one, we'll say AX. In the next one, we'll say gray image inverted. Okay. So this is the name we gave, and let's run this. We will get our steps done. Oh, so this is what we were looking for. Look the steps we went through and this. Okay, so this was the final sketch we got. Now look here. So first we got our images, we printed. Next we said we converted into a gray image. So this was a colored image. We converted it into a black and white image. Next thing we said, we just inverted our images with 255 minus gray image. So wherever it was black, it will become white, and wherever it was white, it will become black. Next thing we did in this CV2 dot Gaussian blur. So what we did, we just blurred the image. Look, on this image, on this inverted image, we made a Gaussian blur. After that we made this. We divided our gray image. So we divided this picture from 255 minus gray image invert. So we inverted this image. So here you can see we again inverted 255 minus gray image inverted. So we inverted this and divided with this picture with a scale up to 56. So whatever white and black was there, it got and it converted into this kind of images. All right, so that was all for today's video. I hope I could make it interesting for you all to understand how this image our original image is converted to an sketch image in using our Python Opencv library with a step by step for here. So thank you for watching this video. In case you like the video, please make sure that you subscribe to my channel, like the video, comment down your thoughts. If you are willing to look for the source code or something like that, so here is open for you. You can easily write them down. All right. So thank you guys for watching this video. Hope to see you soon in my next video. Thank you.